Welcome back, guys. We're starting section 9.2, which is looking at formulas of area for circles and polygons. If you recall, we've done triangles, rectangles, parallelograms, we've done kites, a rhombus, we've done trapezoid. I'm trying to think if I'm forgetting any. So we're going to jump into a little bit more difficult ones, circles and polygons. We're going to start with polygons today and just do those. You know how to do a triangle, which is a three-sided shape, and you know how to do a quadrilateral, which is a four-sided shape. But we're going to look at five-sided shapes, six-sided, seven-sided, so pentagons, hexagons, heptagons, octagons, even dodecagons. Again, I'm not very good at drawing these, so if you ever need to, I just go onto the old internet and search like hexagon shape, and then sometimes I will just pull that into my Notability so that I can draw or trace over it. Okay, so we're going to start with polygons. This is a hexagon, so a six-sided shape, a regular hexagon. A couple vocab words. The radius of this hexagon is actually if you go from the very center to one of the points. So like from here to here. The reason they call it the radius is if you drew a circle around that shape. Let me get a little smaller. Then it would be the radius of that circle. So that's why they call that the radius. The center obviously is the center of the shape, but the new word is apothem. So if we're looking at this hexagon, the apothem is if you draw straight down, making a right angle, straight down from one of the sides. And if you notice, it's kind of like this hexagon has since it's six-sided, six little triangles in it. So I use the area of a triangle to help me figure this out, and then just multiply by the number of sides. This is 6. If you'd like an official formula, the formula is the area is 1/2 times the apothem. And again, that is this right here. Or if you're looking on the side, it would be right here, that distance, times the perimeter. If you're so that's the area of a polygon. I don't actually use this formula. Instead, what I like to do is I just like to look at the shape as a bunch of triangles smushed together. And I find the area of each triangle, which would be 1/2 times base times height. And the height would be the apothem here. I remember apothem because in the Batman movies or in the Batman comics, there's a city called Gotham, and it rhymes with that. So Gotham, apothem. That's how I kind of remember it. But that's like the height of one of those triangles in the hexagon. And then I just find each of those and I multiply, I find each of them, and there's 6 in a hexagon, so then I would multiply by 6. If it was an octagon, I'd multiply by 8, etc. As long as it's a regular shape. So all sides and angles are the same in there. So let's start one step at a time, and we'll build up to finding the area of the whole thing. We're going to do a lot of trigs, so get ready. Okay, so here they start us out, and they gave us a lot of information. So they said the apothem is 4.9 and a side is 7.1. So I'm going to kind of break it. This is a pentagon. I see 5 triangles in here, penta meaning 5. And they told me the side is 7.1 inches and the apothem is 4.9 inches. So if I wanted to find the area of just this one triangle, then I would use the area of a triangle, which is area of one triangle is 1/2 times base times height. And I know the base to be 7.1 and the height is 4.9. Type that in my calculator. And I'm going to get 17.395. So 17.395. And so that in inches squared is just one of the triangles. But in a pentagon, I've got 5. So the area of the pentagon would be equal to that number times 5, which gives me 86.975. And my unit is inches squared, and that is the area of the whole pentagon. So that starts us off nice and basic, where they gave us some of those heights. Oh, it's wanting to draw some weird shapes. Close enough. Okay, so they are giving us the apothem in the side. Let's try one more just for good measure. A hexagon. I'm not great at drawing a hexagon, so I'm going to grab one off of the old internet. And let's see, images. And let's use this one. Bring Notability up here. See if I can drag it right on there. So go back to Notability. And here I have my hexagon. So the apothem here, I'm going to draw my center, draw my triangles. Okay, now I have 6 triangles, and one side is 14 feet, and the apothem is 12.1 feet. So again, the area of one triangle, so like, get my colors in order. My area of one triangle, so like this one right here, would be 1/2 times base times height. So that base is 14 and the height is 12.1. Type that all into my calculator and I get 84.7. And the unit was feet here, so feet squared. So that's just one triangle. A hexagon has all 6, so we can say the area of the hexagon is just equal to that one triangle, 84.7 times all 6 sides. So that area of the hexagon, when I type it into my calculator, is 508.2 feet squared. So one area you could use this is like if you were measuring the stop sign. You could measure to the middle from the bottom and the side length, and you could find the amount of material you would need for that stop sign. So that's starting us out finding the area when we're given the apothem and the side. Sometimes they're not going to give us those. They're only going to give us one of them, and we're going to have to figure out the other one. That is where some angles and trig comes in. So let's just start with the angles before we add the trig in. So here we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So we have an octagon. And they want each regular polygon has the radii and the apothem as shown. Find the measure of each numbered angle. So the problem here is they didn't tell us the angles, which we didn't know earlier, but they gave us other information. So I'm going to try to, before we do trig, we're going to try to figure out what some of these angles are. So we've got 8 triangles going on here. So if they, let me draw this first. So my shape is made up of 8 different triangles, and I want to figure out the angle in each one. So if you think of this as one circle of angles on the inside, circles are 360 degrees. So again, all those angles make a circle, so 360 degrees in the angles, and if there's 8 sides, Then I can divide by 8, as long as it's a regular polygon, and that will give me each angle in the center. So 360 divided by 8 gives me 45. So this is 45 degrees, and this is 45 degrees, and this is 45 degrees, etc. So if this whole thing right there is 45 degrees, if I wanted to figure out the apothem, then I'm going to be making this into a little right triangle right here. So we'll have to figure out angle 2 and 3. And they also, that one would be a right angle because that one's a right angle. And they add to 180 for the straight line. So if this whole thing was 45, I can get this piece by cutting in half because the apothem will cut that triangle in half. So 45 cut in half is 22.5. 22.5 is that angle. And then to find angle 3, the pink triangle makes 180 for all the degrees. So I can do 180 minus the 90 degrees minus the 22.5 degrees. And that will give me 67.5. So this angle is 67.5 degrees, right in there. So we're going to use that later to find the apothem, but I just want to show you how to do that first. We'll practice one more together. This one is a pentagon. So we have 5 sides or 5 different triangles. Here's 1, 2, the third one, fourth one, and that last one. So in order to figure out what that angle is, again, they make a circle on the inside like this. And so those angles need to add up to 360. So 360, there are 5 sides. If I type that in my calculator, I get 72 degrees for each. If I split this in half for this mini triangle so that I can try to find the height or that apothem, this angle should be, what would I have to do? I'm going to cut that 72 in half, and that should give me 36 degrees. This is a right angle right here. So to find angle 3, I'm going to do 180 minus 90 minus 36, and that will give me angle 3 to be 54. Feel free to email me if you have questions about that, but we are gonna put that whole puzzle together. So the beginning, I was showing you how to find the area when you know the apothem and the sides. Then we use this to figure out what the angles are. Now we're gonna put it all together. So what if you do not have as much information as they gave you the first time? What if they only gave you one of the sides? So here we have a hexagon. I'm going to draw my triangles. And I know that each side is worth 12. The reason is it says it's a regular polygon. So this is 12 inches, 12 inches, 12 inches, and 12 inches. So in order to find the area, I need the apothem, which would be this right here. And we're going to use a little right triangle trick to figure that out. So first I have 360 degrees divided by 6 sides is 60 degrees for each of these. So if this whole thing is 60 right here, then this half would be 30. This would be a right triangle, and we could find this one by doing 180 minus 90 minus 30, and that should give me 60 degrees. It just so happens to work out that it's the same as this one over here. So that's 60. Now if you notice this pink triangle right here, I have a right triangle, and I can use trigonometry. Good old SOHCAHTOA, 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 SOHCAHTOA. I know you've missed that song, to find out what the apothem is, or the height of this triangle. So the base is 12 total, but this half would just be 6. So if I'm trying to find that height right there, let's just call it X. I can either use the 30 degrees or the 60 degrees, either one, and then do trig from there. I'm going to use the 60 degrees just because. So if I'm looking at 60 degrees, I have the opposite from it, which is X, and I also have the adjacent, which is 6. So opposite and adjacent would be tangent. So tangent of 60 equals X over 6. I know I had been typing tangent 60 and getting a number right away, but I'm not feeling like writing all those decimals out. I think it's a little bit more concise and might help you if you just kind of leave it as tangent 60. If you want to write the decimals out now, you can. But I know that next I'm going to have to multiply both sides by 6 anyway. So I'm going to type 6 tangent 60 in my calculator, and I'm going to get 10.39 equals X. So now I have the apothem. Side note, if you wanted to use 30 instead, you could say tangent of 30 equals, this time the opposite is 6 and the adjacent is X. You would multiply both sides by X. X times tan 30 equals 6. You would divide both sides by whatever number you get for tangent 30 in your calculator. And you still get that 10.39 to equal X. So either way you want to do it is fine. But we know that this is our apothem, or our height of that triangle. So let's try to find the area of this whole green triangle now that we know our apothem. So the area of a triangle, area of one triangle is 1/2 times base times height. The base in our case is 12, and then the height we got from the apothem, which was 10.39. All you got to do, just like before, is multiply that on your calculator, and we'll get 62.35. So that was one triangle. It looks like we have a hexagon. So the area of the hexagon is going to be that 62.35 times all 6 triangles, which will give me a total of 374.12, or 374. And the unit there was inches squared. So what this would be used for is if you have some kind of shape besides a triangle or a rectangle, and you need to, let's say it's tiles or stop signs and they're printing them off with sheet metal, you need to know how much you need. So that's just one example of finding the area. Let's do one more. This time, I'm going to actually change this problem. I don't want to do that one. Let's do what shape should we do? Let's do an octagon. Octagon shape. Oops. And we'll bring this one in. We'll do that instead, just because I want you to see something a little bit different. So cross this guy off. We'll do our own shape instead. This time, instead of giving the side length, what if they gave you the apothem this time instead? So if they gave you this distance, I'm going to make it up. Let's just say they gave you 10 feet. What would the area of this octagon be? So maybe if you measured the stop sign and you measured from the top to bottom and found it to be 20, so the apothem would be cut in half, 10, and you wanted to know what how much metal was used in the stop sign. So again, cross this one off from your notes. We are going to do a different one instead. I just decided on the fly. This one's a little bit different because they gave us the apothem. So same steps, 360 divided by, there's 8 sides. That gives us 45 for each. So if this is a right triangle, this would be 22.5. Let me see if I can scrunch it in there. Degrees, shrink it down. Ew, so tiny. Oh yeah, it fits in there. Then I will do 180 minus 90 minus that 22.5. And that gives me 67.5 degrees for this spot right here. So I will put that in. We know the apothem to be 10 feet, but now we need to figure out what the base is. So when we're doing it, we're really only finding half of the whole base because that's the right triangle that we're going to use, just because the right triangle is easier than doing a non-right triangle. So you can either use the 22.5 or the 67.5. I'm just going to do one of them this time, but just like before, either one will work. So let's use 22.5 this time. So we're looking for this. That would be the opposite, and the 10 feet is the adjacent. Opposite and adjacent. So TOA, opposite adjacent. So TOA, tangent of 22.5 equals x over 10. So multiply both sides by 10, and 10 times 10, 22.5. That gives me 4.14 equals x. So now that we have that is just half of the base. So if we double it to get the base of the octagon, or of this triangle. Okay, so now we can find the area of one triangle. So the area of one triangle is 1/2 times base times height. Let's move this stuff up a little bit. I'll just keep writing. And the base is 4.14 times 2, so 8.28. That's a big spot that people miss. They just use the 4.14, but don't forget that's only half of the base of the triangle because we're now looking at this light pink triangle, that whole thing. So that times the height, which is the apothem we were given, which is 10, and that will give us 41.42. So that is one of the triangles. Since it was a good old octagon, we're going to multiply by 8. So the area of the octagon is 41.42 times 8, which gives you, let me type that into my calculator, 331.37 feet squared in area. So 10 feet seems kind of crazy for a stop sign. 10 inches, that seems a little more realistic for the apothem. But you could find the area for a stop sign this way. So kind of to wrap up, what you need to do is find the area of one triangle using 1/2 base times height, and then multiply by the number of triangles in the shape. You might have to find the angles on your own, and you might have to use trig to find the apothem or the base. Let me know if you guys have questions on the homework, and enjoy. Talk to you later. See you soon. Hopefully. Bye.